Hello, this is lesson 9.2, day 2. Today we're looking at the sum of a finite arithmetic sequence, and this is when n represents the number of terms like it has been. Then we have the sum of those terms equals the number of terms divided by 2 times the quantity of the first term plus the last term quantity. So we're going to look at some problems from the book. We're going to do some even ones. You'll have the odd ones for your classwork. So let's see which one to start. 58. Let's start with 58. The directions say to find the indicated nth partial sum of the arithmetic sequence. Make sure you've written down that formula. We have the sequence given or started, and it says n equals 10. So they want the sum of the first 10 terms. We're going to use our formula just by looking. I think I wrote the wrong problem. That's actually 57. So actually we'll do the first, since you already wrote that. This is 57. This is your first or one of them in your classwork. So we'll just do 57 then. So basically we can see that our first term is the 8. That's going to go in our formula. We can see that the common difference is 12 because we take 20 minus 8, which is the 12, or 32 minus 20, or 44 minus 32 to get the difference. And we know that n is 10. They told us that. So to plug into, first of all, we have, what else will we need? We need the a sub n. So since n is 10, we need to find a sub 10. So to plug in for a sub 10, that would be a sub 1 plus 9 times 12, which gives us 116. I guess I could write just above here. This was the a sub 1 plus the n minus 1 times the d. So that's where the 9 came from. But we get 116 for a sub 10. So now we're going to plug into the formula. So we need the sum of the first 10 terms. That would be 10 divided by 2 times the first term, 8, plus the last term for the first 10 of 116. So when we calculate, that would be 5 and then times 134, and then we get our sum to be 620. So the sum of the first 10 terms is 620. So let's look at another. All of those in that section are asking for, the same type, but let's look at 65. It looks a little different. They tell you to find the sum of the first 100 positive odd integers. These are actual ones from your classwork. So if I think about the first positive odd integers, that's 1, 3, 5, 7, and so on. So let's think about what that nth term would be. Well, I can see the common difference is a 2, and 2n would be the first part of the rule. 2 times 1 is 2, but this first term is a 1. So I'd subtract 1 from it. So 2 times 2 is 4, minus 1 is 3. So this nth term is 2n minus 1. We need to know the rule because then we're looking for the sum of the first 100 positive odd integers. So we know that the a sub 1, just kind of gather my information, is a 1. And then to find a sub 100, we're going to plug into that rule we just said, 2 times 100 minus 1, which would be 199. And so we need to find the sum of the first 100. So that's a 100 divided by 2 times the first term plus the last term. So when we calculate, we get the sum of the first 10 positive odd integers as 10,000. Next, we're going to look at a different way they write it, and that's called summation notation. I'm going to look at 68 with you, but I'll kind of dictate what that looks like. It looks like a crazy kind of a capital E, but a weird one. But this is the sigma notation, which is a Greek letter, but it's standing for the summation, summing, partial sum. So the way that this one is written, they put basically this, we're starting for n equals 1 up to 100, and then this is the 2n that they write beside it is the nth term that they give us. So you'll see that sometimes when they write it in this notation. So this one really just wants the sum of the first 100 terms for the rule 2n, starting with a 1. So just plugging into the same thing we already knew, because the first term, I'll just put it over here on the side, 2 times the first term is 1, 2 times 1 is 2, so the first term is 2. They're saying that n starts with 1, so we're having from the first term. And then the last term, which would be a sub 100, would be plugging in n for 100. 2 times 100 is 200. So the 100th term is 200, and then we already said that we're looking for the first 100 terms, which is that number on top. So we're going to find the sum for the first 100, which would be 100 divided by 2 times the first term, we just determined 2, and the last term 200. When we calculate, we get 10,100. 72 just is going to have a summation of 2 of them put together. So I'll jot down this real quick. This one we're just going to do each one separately and then subtract. So the first one, kind of putting it all together, I'm going to say, well, we have the first one, and then we're going to subtract the second one. So initially, kind of like we did above, this rule, both of them are n, so the first one is going to be a 51, but we're going to have the if I take 100 minus, because I'm not starting with the first term, so basically if you take the 100 minus the 51, but then you have to add 1 to it because that's where we're starting, so that would be asking for the first 50 terms. This one's asking for the first, the sum of the 50 terms, starting with 51 and going through 100. So that you just subtract them and add 1 to it if it's not a 1 starting. All right, so then the first term, when we plug a 51 in for n, that's a 51. And then when I plug a 100 in for the last term, that's 100. For the second one, since we're starting with 1, I can use the same rule. 50 minus 1 is 49 plus 1 back. You always have to add the 1 back, but 50 divided by 2 times 1 plus 50. So for just this piece, this front one, we get 3,775, and the second one we get 1,275 when we calculate, and then last we can subtract, and we get the sum to be 2,500 for the total after we did the subtraction. Now we're going to look at a couple of word problems, and then we'll be done. The 82, you're going to have 81 like this. They say to consider a job offer with the given starting salary and the given annual raise. We're going to determine the salary during the 6th year of employment. and determine the total compensation for the company through 6 full years of employment, which would be the sum of the first 6 years. So for 82, we're going to first find the 6th year of employment, what they would earn. So they tell us for 82 that the starting salary is $36,800, which would be our A sub 1, $36,800. And then they tell us the annual raise. Well, that would be our difference, because if that's what it's going up by each year, then that's our D. So just to find the A sub 6, we would need to plug into our formula, which would be A sub 6 equals the A sub 1 plus n minus 1 times D. And since n was 6, then we're going to put a 6 for n. So A sub 1 is 36,800 plus 6 minus 1 is a 5 times the D value. So when we calculate, we get that A sub 6 is, and it is money, for $45,550. That would be the salary for the 6th year. So for part B, we want the sum. We want the sum of the first 6 years. So using all the pieces that we just have now found, we have the n, 6 divided by 2 for the formula, times the first, and then plus the last, which is what we just calculated. And then it's just the fact of calculating it, and for time's sake, this is what it comes out. And the last, 84. Determine the seating capacity of an auditorium with 36 rows of seats if there are 15 seats in the first row, 18 seats in the second row, 21 seats in the third, and so on. So first thing we want to do is kind of look at that sequence. So I can see that 36 total rows, but we go first row 15, we have 18, then we have 21, etc., etc. So we are looking to find the sum of the first 36. So we know we're going to be doing the S sub 36. What do we need? We need the first term, which we do have the 36 over 2 times the first term is 15, but we need to find the last one. So we need to find what A sub 36 is. Well, A sub 36 would be A sub 1, which is 15, plus n minus 1, which n is 36 minus 1 is 35, times the difference. 18 minus 5, the difference is a 3. So when we calculate the last number of seats in that last row, 36th row, we get 120 seats. So doing the calculation of this, we can see that we have 2,430 seats in that last, in the first 36 rows total. Summation. That is all.